Sparks due to switching off a circuit of large inductance. In the shown experimental simulation, we have a battery, a lamp, an ammeter, a resistor, a coil of large inductance, and a switch. When this circuit carrying a current I, observe what will happen when we open the switch abruptly. Let's turn on the simulation. Now, a current is 69.2 mA in the circuit. When we open the switch abruptly, sparks appear at the switch contacts. Therefore, when a circuit of large inductance carrying an electric current is opened abruptly or suddenly, sparks appear at the switch contacts due to a very high voltage across its terminals originated from the high electromotive force induced in the coil. What happens when we open the switch, or why the induced electromotive force is very large in the coil? Answer: when the switch is opened suddenly, the current decreases to zero during a time delta t. In our experimental simulation, during the transient phase, the current decreases from 69.2 mA to zero. So during the transient phase, the current varies. So the magnetic field crossing the coil varies. Therefore, the coil is crossed by a variable self-flux. So it is the seat of a self-induced electromotive force.
Observe this simulation. I will close the switch. So the current flows out from the positive pole of the battery. At this junction, we have two branches, the branch of the coil and the branch of the diode. But the diode is reverse biased, so it acts as an open switch, and the branch of the diode carries no electric current. So the current passes in the coil from left to right. Now the coil here acts as an electrical load or receiver, and it stores magnetic energy. Now I will open the switch. Observe. Pause. Now I pause the simulation. What happens when I open the switch? Now the coil will act as a generator and supplies its magnetic energy to the circuit. Here the current flows in the coil from left to right. At this junction we have two branches, the branch of the open switch and the branch of the diode. The open switch has a very high resistance, so no current passes in the branch of the open switch, and the current passes in the branch of the diode, which is forward biased now, so it carries electric current, and the magnetic energy stored in the coil is transformed into thermal energy in the resistors of this branch. And in this case, we avoid the damage at the switch contacts because there is no current in the branch of the switch.
Watch this simulation. A capacitor is connected in parallel across the switch. The current now has a value of 87.4 mA. When we open the switch, free damped electromagnetic oscillations take place and no sparks appear at the switch contacts.